In this video, I'm going to show the workflow I usually use to create 3D characters, and I will use as example a prototype I did with a friend few months ago. I will cover some of the technical aspects of the workflow, but I don't intend this video to be a detailed tutorial that you can follow step by step. It's more for me to share with you a behind-the-scenes process that I use when working on my games. So for this character we call him Handman. The idea was like he's a buff guy who instead of a head he has a hand, and he's aggressive, he has a chainsaw, he's a very aggressive dude, he's buff, he's that kind of character that is a melee character, you know. So with this idea in my head, I went directly to the 3D software I use to sculpt, that is Blender in this case, and I started modeling what I envision the character should look like, right? I start with a base mesh that helps me define the outline of the character without too much details on it. After that, if I'm not familiar with what I'm going to sculpt, I usually look for a lot of references, and this is the way you learn anatomy, for example. In my case, I'm not an expert on this, but since I didn't want to create a very realistic character, I just went ahead and gathered some references and get inspired by them and add detail on the mesh itself, right, until I have something I'm happy with. I like to spend time sculpting. It's a very creative process, and I can work very long hours without getting tired or losing focus. But usually I cannot get crazy with the amount of hours I put into creating a model, because there is a lot of things that needs to be made before finishing a prototype, and all of them are important. So I need to let go some of the details while trying to get a nice looking character. So after finishing the sculpting, this is the first step to create a character. You need to convert this high density vertex count mesh into a low poly mesh. Game engines usually cannot move more than 1 to 3 million vertices per frame. If you have a very fancy graphics card, then you can move like more than that. But if you want to make a game that works in everybody's computer, then you need to keep your vertex count low, right? So first step after finishing the sculpting is to convert this high poly into a low poly for real-time game engines. And to do that, you can use a technique called retopology that basically consists in recreating an existing surface, in this case the high poly mesh, with more optimal geometry. There is many ways of doing a retopology. I usually do it in Blender, but for this model I wanted to do the retopology as quick as I can, and I used a tool called Topogun. It's not a very creative process, but I enjoy it anyway, because for me it's like playing a game where I have to find a solution for recreating the high poly mesh with as little vertices as possible. Here again is a game where you need to be efficient. You cannot get crazy in the amount of hours you spend doing the retopology, because nobody will see this. If you have a clean mesh, only you as an artist or as a developer will see that you did a good job doing this. So when I was learning how to do retopology, it was very frustrating because I was not able to achieve good results in a quick way. So the only way to master this technique is by doing lots of retopologies. Usually the most important part of the low poly mesh is to maintain a quad geometry to help you later with the remaining parts of the process. The advantage for quad topology is that you ensure a clean mesh, especially for subdivision. The ability to easily add edge loops on a mesh, and ability to properly deform the model for animation. It's something that makes your life easier as an artist at the end of the day. Once you have finished your low poly mesh, you are ready to do the UV maps. These UV maps are going to be very useful for you to create the textures that will bring the detail to your model. Low poly mesh itself doesn't have too much detail definitions or details itself, and the game engine uses textures to add detail on top of this low poly mesh. A UV map is the way you tell the computer or the engine how this engine should map a 2D texture on top of your 3D mesh. And one of the most important textures for a game character is the normal map. In 3D computer graphics, normal maps are a technique that it's used for faking the lights on a surface, how the light affects our low poly mesh. It's used to add details without using more polygons. And the objective of creating this normal map is to transfer the detail from the sculpt that we did with the high poly mesh and into the low poly mesh. And this process is called baking textures. Basically, what you do is to put the low poly mesh on top of the high poly mesh, and the 3D software will calculate the distance out of the low poly mesh and starts casting rays inwards towards the high definition model. And when a ray intersects the mesh, it records the surface details and it saves them into a texture map. Once you have a low poly mesh with textures, the last step you require for it to become alive in your game is to move. And for making a mesh made of vertex to move, we use bones in a similar way that your muscles are structured. Digital Characters uses bones to tell the game engine how the vertex should move. And the way to link a vertex with a bone is called vertex skinning. The intention of this technique is never to imitate real anatomy or physical processes. There isn't any physical calculations for the muscles in most of the games we play today, especially in indie games. So the bones that the character has are used only to control the deformation of the mesh data, to make the animation process more intuitive for the animator who is going to work on it. So imagine it's like moving some kind of digital puppet as a tool to narrate a story. Although the model I created is just a bunch of vertices with a texture on top of it, if I want the players to enjoy the game and empathize with the character itself, those vertices has to feel alive. They have to recreate emotions to help convey a story, to express anger or pain depending on the situation. And these bones allow the model to have movement and facial expressions to help the players believe that the 3D model truly fits seamlessly into the world where the game takes place. So yes, animation is a huge part of bringing characters to life.